According to the 2020 National Electrical Code, a ground fault circuit interrupter, known as a GFCI, is required for all 120-volt, 15 and 20 amp receptacles installed in specific locations. These locations include bathrooms, garages, outdoor areas, crawl spaces, unfinished basements, and kitchens, specifically at countertop outlets. The NEC also mandates regular testing of all GFCIs, requiring monthly tests to verify their proper function. The requirement for GFCI protection is tied to the presence of 120-volt, 15 and 20 amp receptacles in the specified areas, irrespective of the overall service rating or the size of the main breaker. In the scenario presented, although the service is rated at 1 kV and the main breaker is an 800 amp breaker which is adequate for the load, the service is still considered a high fault current location due to its 1 kV rating. Consequently, a GFCI is still required for all 120-volt, 15 and 20 amp receptacles installed in the bathrooms, garages, outdoor areas, crawl spaces, unfinished basements, and kitchens with countertop outlets. The rationale behind this requirement is to provide enhanced protection against electrical shock in locations where the risk of contact with water or other conductive materials is higher. GFCIs work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference in current, indicating that some current is flowing through an unintended path, such as a person, the GFCI trips the circuit very quickly, typically within milliseconds. This rapid response minimizes the duration of the electrical shock, significantly reducing the risk of serious injury or death. Testing a GFCI is a straightforward process. Most GFCIs have a test button and a reset button. To test the GFCI, push the test button. This should cause the GFCI to trip, interrupting the circuit and cutting off power to the receptacles protected by the GFCI. To restore power, push the reset button. If the GFCI does not trip when the test button is pushed, or if it cannot be reset, the GFCI is faulty and should be replaced. Regular testing is crucial to ensure that the GFCI is functioning correctly and will provide protection when needed. The NEC requirement for GFCI protection is based on extensive research and analysis of electrical shock incidents. The code is updated regularly to reflect the latest safety standards and best practices. The specific requirements for GFCI protection can vary depending on the edition of the NEC that is in effect in a particular jurisdiction. It is important to consult the current edition of the NEC and any applicable local codes to ensure compliance. In addition to the locations mentioned above, the NEC also requires GFCI protection in other areas such as boathouses, healthcare facilities, and commercial and industrial locations where there is an increased risk of electrical shock. The NEC also provides detailed requirements for the installation of GFCIs, including the proper wiring methods and grounding techniques. It is important to follow these requirements carefully to ensure that the GFCI functions correctly and provides the intended level of protection. There are several different types of GFCIs available, including receptacle-type GFCIs, circuit breaker-type GFCIs, and portable GFCIs. Receptacle-type GFCIs are installed in place of standard receptacles and provide GFCI protection for the specific receptacle and any other receptacles that are wired downstream from it. Circuit breaker-type GFCIs are installed in the electrical panel and provide GFCI protection for an entire circuit. Portable GFCIs are designed to be plugged into a standard receptacle and provide GFCI protection for any equipment that is plugged into the portable GFCI. When selecting a GFCI, it is important to choose one that is rated for the specific application and that meets all applicable safety standards. It is also important to follow the manufacturer's instructions for installation and testing. GFCIs are an essential safety device that can help to prevent electrical shock injuries and fatalities. By understanding the requirements for GFCI protection and by properly installing and testing GFCIs, individuals and organizations can create a safer electrical environment. It is also worth noting that arc fault circuit interrupters, known as GFCIs, are different devices designed to protect against fires caused by arcing faults. While GFCIs protect against electrical shock, GFCIs protect against fires. The NEC also has specific requirements for GFCI protection in certain locations. The code requirements are in place for safety. Therefore, regardless of the adequate rating of the 800 amp main breaker for the load, the WINC service rating mandates GFCI protection for 120 volt, 15 and 20 amp receptacles in specified locations. Always refer to the latest edition of the National Electrical Code and local amendments for the most accurate and up-to-date information. Moreover, it is important to remember that electrical work should only be performed by qualified and licensed electricians. Working with electricity can be dangerous, and improper installation or repair can lead to serious injury or death. If any questions arise about electrical safety or code compliance, consult with a qualified electrician or electrical inspector. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.